Alright everyone, so we are now ready to solve the second question of our weekly contest, which is minimum time to revert word to its initial state 1. How do we do it? How do we do it? So the trick here is, well, first I'll read you the question. You are given a zero index string word and an integer k. At every second you must perform the following operation: remove k characters from the characters of word and add k characters to the end of the word. Okay, so k from the beginning and add k to the end. Okay, so return minimum nine times greater than 0 required for words to revert to its initial state. So we cannot return 0 here. We because we have to perform at least one operation. After that, how many operations does it take to reach to the initial state? Okay, so the trick here lies in, we have to find the longest string from the back which which can be put at the front. Okay, so for in this case, the longest string from the back, excluding the first four characters, that can be put in the front. So for in this case, it's going to be ABD, sorry, ABA, right? Because ABA is here as also and ABA is here also. Okay. Well, what is it going to be in this case? After slicing the first three characters, we have C, A, B, A. So what is the longest string from the back, cutting from the back, that can fit at the top, at the beginning of the initial string? So here we see that ABA, here ABA can be put at the beginning, ABA, right? So here the longest string is of length 3, right? So now we see that now we have to calculate that after how many steps do we reach this position. So to reach C, how many steps do we need? So in the first step, ABA, we slice this, right? Slice K. So we are left with CABA, right? And in this step, what we simply need to do, we simply need to, keeping that in mind that we are going to use this ABA at the beginning, we will be adding our, accordingly we will be adding our three characters at the end. So after ABA, what are the three characters? CAB, right? So CAB will be added, and our next current string is going to be like this. And in the second step, we will be just removing C and we will be just adding A, right? So we'll be getting our required number. That is going to be two steps, right? Similarly, in this case, our k's value is 4, right? So we just have to check that how many, the longest string, which should be greater than 1 actually, which because k's value we can slice any number from 1 to k. Okay, but we cannot slice 0 numbers. We at least have to slice one number. Okay, so here we have to check the longest string that can fit at the top. So we see that this is going to be the longest string. Just to I'll just rewrite it. So for this case, A B A C A B A, which is the longest string which can fit at the beginning. So we see that what do we need? A B A C. Okay, so we see that A B A, this can perfectly fit here, ABA, right here. So now how many steps do we need to reach this part? this position, which is here, this position at C. So here, as you can see, the K value is 4. So we, in the first step only, we can slice these 4 elements, and we'll be at ABA, and we'll be putting the required string, whichever string we need to make it, first 4 characters. We can put any 4 characters. We are going to put those 4 characters which make this string back to its, back to the initial string. So the trick here is just to find the longest. First we have to just find the longest string from the back which can fit at the beginning, and then we just have to count the number of steps we need to reach that string. That's it. So how can we do that? Well, I'll show you how can we do that. Let's jump to the code. So I'll just get rid of this. Let's jump to the code. So first, what do we need? We need for loops for I in J, for I in range, len of word, and we can jump from, from one, or we can jump k steps, right? K steps. We're gonna be jumping k steps every time. So we can, what are the maximum number of steps we can take? So the quicker we travel, the quicker we reach our desired position. So we'll be traveling in the first step onwards, we are going to be jumping k steps. Well, somebody might say that's not a good idea to jump k steps, but yeah, it will work, I think. Answer. Now our answer, what is the answer going to be? So we are counting the number of steps we need to reach our desired position, which is the position I explained earlier, right? The position where we see that this string can be, the string starting from that position can be used at the end, at the beginning as well. So we are now we are counting answer plus equals to 1, and we will also be needing to declare answer equals to 0 here, right? Now what do we need? To we will be traveling k steps, k, we will be jumping k elements at each step. Now we will check here, after jumping we will be checking if the word which is starting from I to the end is equals to word which is after slicing from the end. So here, what are we checking? We are checking that is is the string which we have just sliced is equals to the string of the initially the word, our initial word, right? That's what we are checking here. And if it does satisfy, what we will be returning here, return. And if it does not happen, then we will be returning, because eventually we will be, after removing the words from the beginning, we will be reaching a point where we have removed all the words of the initial string and we have placed all the new words according to our need. So this is one way of doing it. Let's try to run it. We see that we run it, our answer comes right, and let's try to submit it, and the solution is accepted. Now I'll just show you the solution will work for the other one as well, which is going to be, 1 second, So the same solution can be used in this question as well, which is at the end. We'll be just pasting the same solution. We'll be just running it. It runs it runs fine, and it is accepted. So thank you for watching. Stay tuned for the next solution, which is going to be of this, the tricky one.